In this chapter, we are going to talk about things like probability, how do you count things, series and sequence, that kind of stuff. So we're going to just start with the basic stuff, basic combinatorics. So basically, figuring out how you count things, how many combinations, can this happen, that kind of stuff. All right, first one. How many different ways can 3 letters A, B, C be arranged in order? How many ways can 3 letters A, B, C be arranged in order? What do you think? 9. That is not correct. 6. Yes, correct. 6. Now, how do you, let's come back to notes. So let's take this. Okay. So how do you figure this out? Well, let's think about it. They have to be in order. So let's say you start with A. What can the next letter be? B or C. B or C. So B or C. Now, if you choose B, what letter has to come after that? C. If you choose C, what letter has to come after that?
You can't have any letters.
This is just like the diagram of one possible combination. All right, let's say you choose B. What kind of choices can you have after that?
A and C.
A or C. Okay, and then let's say you choose A. What choice do you have after that? C. And then if you choose C, then you only have A left. If you start with C, the next choice has to be A or B. And then, oh, Zach. Okay, if you choose A, what's the only option left? B. And then if you choose B, then you only have A. So now if you look at all the possible choices, it's going to be 6, right? There are 6 ways. Or what you do is you have 3 different places you're basically rearranging, right? So in the first space, how many choices do you have to start with? 3. And then if you choose one letter, then in the second space, what do you have? How many choices do you have left? 2. And then once you choose that letter, there's only one choice left. And then we multiply that together, we get 6. So this is called the multiplication principle of counting. If you want to figure out if there's a procedure P, and then the procedure P happens in stages, it goes stage 1, stage 2, stage 3, and up to stage N. And stage 1 can happen in R number of ways, stage 2 can happen in R2 number of ways, and so on. Then the number of ways P can happen is R1 times R2 times ... Rn. So what happens is if you have this thing that happens in stages, this and then this and then this, then you count how many ways it can happen in each stage and you multiply them all together. This is the multiplication principle of counting. All right, this is the important part. Please keep in mind how the choices at each stage is affected by the choices of the previous stage. Okay? Because things are going to happen in order. Is this amount of choices affected by the previous stage, or does it not matter? Okay, so we have to think about that before we start multiplying things together. Okay, so for example, the California license plate here shows it's usually 1 digit or 1 numeral digit, 0 to 9, followed by 3 letters. There are 26 letters, and then ending with 3 more numerical digits, 0 to 9. Okay, find the number of different license plate that can be formed. A, if there is no restrictions on the letter or digit that can be used. Okay, first of all, how many digits are, or how many spaces are there total on this license plate? 7. Okay. 1, 2, 3, 4, 5, 6, 7. So we have 7 stages. In the first stage, how many choices do we have? 10. In the second stage, how many choices do we have? 26. In the third stage, how many choices do we have?
26 again because it's not restricted. 26?
Yeah, 26 again because it says there is no restriction. So this is why we had to pay attention to the previous stage. There is no restriction, so 26 again. After that, we have another letter, so 26. And then after that are 3 more digits, and since there are no restrictions, we can repeat. And then what happens is, this is the multiplication principle of counting. You multiply them all together. Okay, so multiply them all together in your calculator, and you're going to get an answer. All right. Okay, so let's see. You should have 175,760,000. Okay, so now let's go ahead and have you calculate if no letter or digit can be repeated. All right, so you should have 78,624,000. Okay. All right. So this is kind of the basic principle of counting. You know, you have stages of how things should happen in order, and then you multiply them together, how many ways each stage can happen, and you multiply them all together. Now we're going to get into a little bit harder calculations. So first, permutation. Permutation means order matters. Okay, P means position because the order things happen matter. If it matters, we're going to use permutation. Now, there are 3 basic types of permutation. First, basic permutation, and the definition is when there is when there is a finite set of n objects, then the number of ways you can rearrange them is n factorial. So this is an example of what we just saw. So we had 3 letters, A, B, C. We want to rearrange them. And because the way we want them to order is that it has to be from left to right. So then there is an order to it. If there's an order to it, we use this basic permutation, which says you just do n factorial. So there are 3 letters, so you basically do 3 factorial. And then we're going to review on factorial. So this is for the previous question. Okay, distinguishable permutation. When there is a finite set of objects, n set. And if n set contains n1 object of the first kind and 2 object of the second kind and so on, so that n1 plus n2 all the way to nk is n, then the number of distinguishable permutation of n set is. Okay, what does this actually mean? So if you have these things that you have this number of things in here, some of them looks exactly the same, that you cannot tell them apart. Then what you do is you take the number of things that's in there, so then n factorial, that's how many ways you can rearrange them. But since some of them repeat, you cannot tell them apart. You're going to take the number of things that repeat, and then you divide out how many ways they can happen. Okay, so what we'll do some practice. Okay, the last one. Permutations of n objects taken r at a time. So if you have so many things and you want to take a few of them and then rearrange them, how many ways can you rearrange them? Okay, so for example, if I have 8 people here, I want to take 3 people and rearrange them left to right. How many ways can I rearrange 3 people out of 8 people? So you have n objects, you want to take r number of them at a time. Then this is npr, okay, which is n factorial divided by n minus r factorial. All right, let's review factorial a little bit. 4 factorial means what? Yeah, 4 times 3 times 2 times 1. Basically, you multiply all the integers consecutively down until 1. You don't multiply by 0, and you don't multiply negative numbers. Okay? only positive numbers decrease by the integers. What is 0 factorial? 1. Okay, so this is just a special property, kind of like 3 to the 0 is 1, that kind of special property. All right, let's go ahead and figure out which permutation problem or method are we going to use to solve each type of problem. Okay, so let's look at just the first one. How many ways can you rearrange arrange the colors of a rainbow? You're going to pick between 1, 2, or 3. Which method are you going to choose to solve this problem? 1, 2, or 3? Talk to your partners. 1, 2, or 3? How many ways can you rearrange the colors on the rainbow? 1, 2, or 3? All right, so you're going to hold up your fingers.
In order.
Factorial.
Oh, no, you're right.
Okay, 1, 2, or 3. Everybody votes. 1, 2, or 3.
We're gonna go with 1.
Okay, 1 is correct. The reason that it's 1 is you are taking 7 colors and rearranging all 7. So that's going to be, and the order matters because you only have one of each. So you cannot say red and yellow are the same. You can rearrange them together. So it's going to be first one, so 7 factorial. There's 7 colors in the rainbow, right?
Technically, an infinite amount of colors.
Okay, I am talking to an artist. That's true. Okay, 7 factorial. Okay, everybody please come back. Okay, first, let's take out your calculator. I'm going to show you where the factorial button is on your calculator. Okay, so take out your calculator. Now, what you want to do is go to, first, type in 7, and I'm going to help you figure out where the factorial button is. You press the math button, and then you go to PRB or PROB, depending on your calculator. PRB means probability, so go to that one, and then you'll see the factorial sign.
Can you take the factorial of the 1.5?
No. It makes no sense, right? You cannot take 1.5 things and rearrange. Yeah. Okay, next. Let's have you guys decide again. How many different ways can you rearrange the 9-letter word dragonfly? It doesn't matter if the word is not in the dictionary. So basically, how many ways can you rearrange 9 letters? How many ways can you rearrange 9 letters? So are you going to use 1, 2, or 3? Talk to your partner. Okay, let's vote. Hold up your fingers. 1, 2, or 3? Okay, people are stuck between 1 or 2. All right, the answer is 1. 9 factorial. The reason being there is no letter that is repeating in the word dragonfly. Okay. Now let's look at number 3. How many ways can you rearrange the letters in bumblebee? Talk to your partner. Okay, number 3. How many ways? So 1, 2, or 3. Which ways are you gonna choose? People over here, gotta vote. 1, 2, or 3? 2. The answer is 2 because there are some letters that are repeating. So, can you guys come back? Okay. Which letters repeat? B and E. Okay, so how many times did B show up? 3 times. How many times did E show up? 3. So what you're going to do is you're going to divide by 3 factorial and 3 factorial. So whichever one is repeating, you take how many of them that is the same, and you put a factorial on it. Because it's just that there are 3 B's, but they look exactly the same. However, they could rearrange. It's just we cannot tell if they look this B and that B switched. We cannot tell. So then we have to divide out the amount of times that showed up.
Does it matter if?
Right, it doesn't matter. But then when we do the 9 factorial, we're counting those ones in our number of ways. So we got to divide it out.
Are you multiplying 3 factorial times 3 factorial?
Correct. We're multiplying 3 factorial times 3 factorial. So let's go ahead and have you calculate what the answer is. Okay, William, what's the answer?
10,080.
Okay, good. 10,080. All right, last one. 16 actors are trying out for the roles of dwarves in the production. How many different ways can the director cast 7 roles? Talk to your partner. All right, 1, 2, or 3 votes. 3. Yes. 16 people. We are choosing 7 of them. And since one dwarf is not the same as the other dwarf, so the position matters, so we're using P. Okay, so 16P7. All right. There is another button on your calculator that has permutation. So you type in 16 first, and then go to the probability section. There's a NPR button, and then you type in 7 after that. It's going to give you the number. So how many ways can you pick 7? How many ways can you pick 7 people out of 16? 57,657,600. All right, let's, so we're not going to do these practices because we are going to do the combination first, and then we're going to practice. Okay, combination. Combination, if you recall from last year, order doesn't matter. Okay, order doesn't matter. So that C means choose. So you're choosing a small group out of a big group. Choosing a small group out of a big group. Okay, so the number of ways you can choose n objects taken R at a time is NCR when the order doesn't matter. Another way that you will often see NCR is this, like this. So you have a parentheses, and then they put N on the top and then R on the bottom. That just means NCR. It's the same. It's just another way of writing it. And if you take stats next year, that's the way they're going to write it. And the formula is N factorial divided by N minus R factorial, which is the same as the permutation formula. But since order doesn't matter, we have less choices, or we have less ways it can happen. So we're also going to divide by R factorial. Yes, you have a question?
So for the test, we don't really have to need to know these formulas.
Correct. You don't need the formula because you can just use the calculator, but sometimes you'll have tests in like SAT or things like that where they will just give you these kind of problems without calculator. So that's why I give you the formula, so then you can memorize it for those kind of tests. Okay, so let's have you and your partner decide. Actually, let's do the first one together. A president, vice president, secretary are chosen from a 25-member garden club. Okay, so is this a permutation question or a combination question? So talk to your partner. All right, let us vote. How many people think it is permutation? Order matters. How many people think it's combination? Order doesn't matter. Okay, it's permutation. Order matters. President, vice president, secretary have all different positions, so position matters. Okay, president cannot also be vice president. All right? Okay, maybe I'll try another one just to make sure. A cook chooses 5 potatoes from a bag of 12 potatoes to make potato salad. Okay, how many people think it's permutation? How many people think it's combination? Okay, good. All right, let's have you guys, you and your partner finish 3, 4, 5. Okay, Jeffrey and George, number 3. Permutation?
I don't think so, huh?
Combination. Okay, so here's what happens. You can argue anything you want. However, there is only one way mathematicians will accept it. So you have to go with that way. And the way it happens is the way you read the question. And there's only one way to read it. So if in the question itself, it's not apparent that there is an order, then you must choose combination. If they're just saying, pick 22 students, you have to choose combination. Even if you're in your mind, you're like, but people, it matters who's sitting in the front, who's in the back. No, you don't want to go in that deep. Just go with the question. The question says 22 students. You're just rearranging 22 students. Go with combination.
Just think of them as potatoes.
Yeah. Yes. Take out the mashed potatoes. Okay, next, let's go with Sky and Taya. Number 4. Permutations? No, combinations. 10 contestants going to the final from 51. That is just, yes, count them as potatoes.
You have 51 potatoes.
All right.
You need 10 really good potatoes.
So it's only
Only the
permutation
taste
that
survives.
actually says something.
Correct.
So
Okay.
everything else is just vague.
Yeah. Zach and John, number 5.
We think it's permutation.
Permutation, that's correct. All right. Now let's do some questions. Okay. The Miss America pageant, 51 contestants.
Wait, a question.
You're choosing 10. Yes,
How does
question.
5 order matters?
Hmm?
If you're just rearranging them, how
Because it has the words have to be from left to right. Like you wouldn't count the same way as from right to left and left to right the same words. Okay, so this one we just talked about it. It's just 51 choose 10. All right. Oh, okay. All right. We'll do more problems tomorrow.